trying to place our sprinklers, we said that it was best to place them in the ceiling plan view. So we went to the ceiling plan of the 4th floor and then linked the CAD file over here. And we did that by checking the current view only box, as in that plan would only be visible in this view. Now that we're going to be drawing the pipes, we're going to have to do that by going in the floor plan. So we had linked our file in current view only, as in we only had it in the ceiling plan and not here in the floor plan. So what are we going to do here? We're going to go to the Insert tab again, then click on Link CAD, and then go in the path where we saved our plan and select it, and make sure current view only box is checked, and the unit was millimeter, positioning center to center, and open. Now we get a message which says at least one instance of this link already exists. What does that mean? It means that at least one of this plan which you are linking already exists in the project. And sure, we are aware, first we linked it in the ceiling plan and now we are linking it in the floor plan. So what's going to happen? It says that the plan you linked in the ceiling plan could be unloaded. Do you want to continue? Yes, we have no other choice and there would be no problem. Now, in order to put the plan in the proper position, we have to align it. So I'm going to use the shortcut AL. Let's zoom in a little, then select the grid A of the model and A grid from the plan to align them, and on this side one of the model and one of the plan. Now I can press the escape key, and thus we have placed our plan in the proper position. Now to start drawing, we've already checked the first two items of the left-hand rule. We're going to go to the Systems tab and click on Pipe. So we've adjusted this carbon steel welded. Then for the system type, we're going to select Fire Protection SPR for sprinkler. And as for the diameter or size, we decided that we're going to be using the millimeter unit. So we have to find the equal metric unit for these imperial numbers. So the equivalent of 4 inches is 100 millimeters. And then what about the elevation? First, we're going to have to create a section along the pipe. I'm going to click here and another one here. We're going to be drawing the pipe along this direction. So let's also minimize this section. I'm going to take this clip to make it tighter down to here. Now right click and go to View. We are here in the 4th floor. And if you look closely, you can see these two beams here. And the pipe which we are going to be drawing has to go below them. So I'm going to get a line dimension and measure from below this beam. Then if it looks like we can't select it, we're going to press the Tab key once and twice, then click down to the FFL, and we get the number 396. So I'm just going to start drawing with the elevation 390. So we get the pipe command again, and now the elevation is going to be 3900, and also we need to make sure that our pipes need no slopes. Even though the slope is off by default, we still have to double check. So now I'm going to go here, click, and click again. Then we see that here it says Control Valve C Detail A, but for now I'm just going to continue with the pipe, and then check the detail later. So click, and then I'm going to continue in this direction. It's all 4 inches, so click, still continuing with 4 inches, click, and then we're going to turn the pipe in this direction up to here, click, and now we're going to go down and click again over here, and then we're going to continue this way, stop here and click. Now press escape. Now we can connect these two together, as in we click on the plus sign of the elbow to convert it to a T, and then drag this pipe which is aligned with this to connect them. So we have drawn this loop. Let's go take a look in section, and as you can see, this is how it turned out. Now this part of it is at a proper elevation from the beam. So is this one. We're going to go a little bit further, this one as well. But here we see that the pipe is interrupting a duct. In order to understand this better, I'm going to go to the total floor plans of the 4th floor and take a look in there. Now as you can see, we have drawn this path, and then we had an interruption with a duct over here. Now if we continue and draw the rest of the branches, we might see another interruption with another item. and basically we would be facing the same problem. Now here for this case, it might occur to me that I can lower the elevation of this duct so that it no longer crosses the pipe. I'm just going to move it a little bit higher, and there we go. Now let's also take a look in the total plan, and you see we had one crossing here which has been solved. Later on we will double check our plan, and if we spot another crossing we will fix it. Let's go in the floor plan and start with one of the branches. For example, here I'm choosing this 4-inch branch. We get the pipe command PI. Now let's check carbon steel, fire sprinkler, diameter 100, which is for 4 inches, and our elevation is 3900, but in case you've changed your elevation in section, you can select inherit elevation, and slope is off. So I'm going to go here, click, and then I'm going to move towards this direction. You see it's all 4 inches to the end. So I'm just going to draw the 4-inch pipe up to here. Now press escape. Now let's go back here to check the beginning of the pipe. And you see something happened here. When I got the pipe command PI and then tried to draw this pipe, the branch didn't connect to the main pipe. It's because the plan we have was visible, and it's like the software took the point in the plan as the connection point but didn't connect it to this pipe. So in case this ever happens to you, in order to have a better, proper connection, you can start drawing from the edge of the pipe. But for now I can just drag this one to this edge, so that the problem's solved. You see we got the T, and now for this branch over here we have 2 inches. So we get the pipe command PI. We'll check the equivalent of 2 inches, which equals 50. And now you see instead of starting from this end point, which is from the plan, I'm going to go a little bit lower to this edge. And as you can see, it highlighted the edge of the pipe for us. If I go here in the middle, and then the axis of the pipe is highlighted, if I start from this point, then the connection will happen. But here it won't. So I'm going to click on the outer edge, and the diameter is 2 inches. And because this is a junction, its diameter changes as it goes. But I prefer to draw my pipe up to here with 2 inches, and then change the diameter wherever I add a junction. When we go further, you will understand better what I'm trying to say. So press escape, and let's go back to the starting point. As you can see, a T has been placed. Now, how should we connect this pipe to each of these sprinklers here? We have multiple ways of doing that. But first, let's head over to the NFPA so we can take a look at a detail. You see here in NFPA 13, we have an expression called return bend, which says if this is your pipe and this is the sprinkler, let me tell you that we're viewing them from above. Now, if you want to connect it to the sprinkler, you can use this return bend set of pipes, or in other words, the upside down U letter. If we look down here, we will see an explanation which says, besides some exceptional cases, return bends shall be used for the parts where pendant sprinklers are placed. Now, what are those exceptional cases which we just mentioned? We also have that explained here. And also the reason of using this return bend is to avoid accumulation of sediment in this nipple. Now, as for those exceptional cases, it says when we have deluge systems, and also if dry pendant sprinklers are used, and also if the K factor is larger than 11.2, in these cases, it is not necessary that we use return bends. As in, we could just start our junction from this side here. But now I'm just going to use a return bend in order to draw the junction. You'll understand later why I chose to do that. So I drew the pipe at elevation 3900, and I'm going to have to draw this junction at a higher elevation. First, let me close the extra views and create a section, click and click. Let's go take a look in this section. We're going to want to see our plan and the section both at the same time. So right click and go to view, and then I'm going to go up to the view tab and click on tile views. Now on the left side we have our section. Also I'm going to minimize its window a little, and on the right side we can see our floor plan. Now we get the pipe command PI. Let's check carbon steel welded, sprinkler, diameter 1 inch or the equivalent 25. And then for the elevation, I'm just going to select something higher and we'll check it later. For example, I'm going to enter 4400. Slope is off. Now I'm going to go click on the center of the sprinkler and go over to the pipe and click on its outer edge. Now you can see very clearly in the section that we just drew a return bend or a U shape. In the plane, I only did 2 clicks, first here and the other here. But if we look in the section, we will see that once the software detected this change in elevation, it drew this U shape for us. Now I'm going to try to connect this pipe to the sprinkler, which is right across from it. So first, I'll have to select this elbow and then click on its plus sign to convert it to a T. And now I'm going to right-click on this T and draw pipe, and draw the pipe towards the sprinkler to connect them together. Then we press escape. Now take a look on this side. You see we just got some kind of a helicopter shape. Our pipes have been connected in a way which looks like the wings of a chopper. Now here's the thing about this part, which is that these pieces, or these pipes, as well as the elbow connecting them, have been drawn with the same diameter as the sprinklers. You remember the size of the sprinkler was 15. So I'm going to have to select this pipe, hold the control key and select the elbow, as well as on the left. Still holding the control key, I'm going to click on the pipe and the elbow, and I'm going to change their diameters to 25. I did that so that the transition will stick to the sprinkler. If you remember, we had the same thing in the CAD file as well. Take a look at here in this detail. It says the transition 1 1/2 is sticking to the sprinkler. Now, about how high this needs to go, do we have limited options? Let's go take another look at the NFPA. And as you can see, here it says that the maximum length that this part can have is 4 inches or 10 centimeters. So let's go back to Revit. We're going to go in section. And now, for example, let's see what the length of this one is. It's 404 millimeters, but we want to make it 100 millimeters. So I'm going to select this one, and I'm going to move it from here down here by how much? I could just type in equals 404 minus 100, then press enter. Now if I click on this pipe, we see that its length is now 10 centimeters. So this is the maximum length. I started to draw it at a higher elevation, and then I changed it to the standard. So that was one way of connecting to the sprinkler. I'm going to go to the View tab and click on Tab Views so we can check out our plan. I can just drag to select this part, then go in Selection Box, and take a look at the pipes in 3D. You see this was the loop we had, then we got a branch to this direction, and another 2-inch branch to this side. And then these pipes were to connect to the sprinklers, not to mention that both sprinklers have been placed on ceiling but at different elevations.